Good evening, everyone. Thank you for joining us this evening. Another excellent turnout, 200 people registered tonight, so that's brilliant. Tonight's talk is part of our autumn-winter online series for the Meadow Makers Network. Now, if you're not familiar with that, it's our online forum. It's a friendly community connecting meadows groups across the Southwest. So if you're not familiar with it, it's free to join and the link is there in the chat. Before I introduce Sophie, just to say that there will be a Q&A at the end. So please put in any questions you have as we go. So without much further ado, I'd like to introduce you to Sophie. Sophie's worked with the Beaver Trust, presenting their award-winning documentary Beavers Without Borders, and she sat on the RSPB England Advisory Committee. She scripted and narrated the multi-award-winning documentary Recovering the Rainforest and co-hosts the Climate Action podcast For What It's Worth. Sophie is also ambassador for the Wildlife Trust and a trustee for UNESCO Exeter City of Literature. And her writing has appeared in New Scientist, National Geographic, The Guardian, The Independent, Frontiers, and more. Tonight, she's here to talk about her latest book, To Have and Told, Nature's Hidden Relationships. I don't know if you can see that. Sorry, my camera's pretty ropey on my computer. But I can highly recommend it. And the book has been longlisted for the 2025 Wainwright Prize for Conservation Writing. So congratulations, Sophie. So I'd like to welcome Sophie.
Thanks, Donna. Hello, everyone. It's a real pleasure to be here this evening, and thank you so much for spending your evening listening to me. So first and foremost, I must apologise. I have come down with a streaming cold and I can only blame the Highlands of Scotland for that. I've just spent the last week with my mum hiking the West Highland Way, and we had Storm Amy to contend with, and we got bone cold despite having a wonderful time with amazing scenery. So yes, I'm a little bit sniffly, but we will forge on. But I'm going to be speaking for about 35-40 minutes, and I'm going to be interspersing that with a video or two and also some readings from the book, some extracts, and then opening up for some questions at the end. And I found in previous talks, the book came out in May in the UK and then in July in America. And some of the Q&A section for a lot of the talks has ended up being my favourite part, because there's something about symbiosis and discussions around how nature binds itself together in these very complicated, very mysterious ways and different relationships that just opens up really interesting conversation that we don't tend to veer towards. So hopefully we'll get some of that tonight. But a bit about me, my background is in zoology, and then I did a master's in science communication. I live in Exeter, I grew up in Devon, and I was really lucky to have the opportunity to write a book for Bloomsbury when I was 25. And so 5 years ago now, and that book was called Forget Me Not. It is a narrative that over 10 chapters explores and spotlights 10 different endangered species who live around the British Isles, and in one way or another they live on the front lines of climate change. And so I go out by low carbon travel, England, Scotland, not Ireland, because I was in COVID at the time, so I was unable to get across the Irish Sea, but go as far as I can to sort of represent what is happening with climate change and endangered species in Britain at the moment. And we meet lots of different experts on the way, so it's kind of like a general introduction to species like merlin, bilberry bumblebees, Atlantic salmon, mountain hares, harbour porpoises, seagrass, grey-longed bats, marsh fritillary butterflies. And it was really important to me that I didn't know much about any of these species when I first started writing about them and travelling to try and find them and researching them, because I wanted very much to be on that journey with the reader where we would be surprised and delighted and interested kind of together along the way. So that was kind of an experimental approach for me, I guess. And then I kind of really honed that in my second book, To Have or to Hold. And I decided to focus a narrative nonfiction book around a specific topic, and the topic is symbiosis. And we'll talk a little bit more in just a moment about my approach to writing about symbiosis and trying to unpick it and trying to better understand it. But it's a phenomenon in evolutionary biology that, despite the fact we probably have all come across the word symbiosis, its actual meaning is still very much undecided and remains a real mystery in science, despite being a very, very important area of biology to study and prioritize, especially when we're looking at conservation practice and how completely impossibly interconnected nature is, from meadows to forests to the soil to the oceans, rock pools, everywhere in between. It's just, we scratch the surface of how everything's bound together. And so I thought it would be good to show you, to get a bit more of an idea, a little video I made with a production company named Sophie Pavelle. I worked with them last year, and it was a kind of like a passion project for me, in that I helped, I scripted the film, narrated it, kind of co-produced it, and working and brainstorming with the film directors, Alexis and Ben, was one of the most rewarding experiences of my career. They just have amazing creative minds, and we gelled really well together to try and bring to life what is a very difficult to imagine situation of invisible ties and strings between species. So I kind of wanted to create a very short teaser of the world that exists within the book, in the hope that it kind of draws you in to what is actually a very difficult subject to sort of wrap your head around. So I'll play the video. Hopefully the sound will work. If not, I'm sure Donna will let me know. But yeah, this is the video of the book. Oh, we don't want that again. Okay, so I guess that was that message at the very end, the "we are never alone," is kind of the overarching message of the book, the overarching takeaway. And I had to record that several times to not sound creepy. But basically, symbiosis as a concept is defined as the living together of unlike organisms. And there are so many definitions and kind of ideas of how to understand symbiosis as a concept, as a reality for the natural world. But I was recommended, and again, a bit like with Forget Me Not, I meet some amazing experts and like top world class researchers whose work delves into the field of symbiosis and beyond. And one of the researchers, who I'll talk about, I think, in a bit, is a Frenchman. called Dr. Xavier Bay. He's based in Brittany, and he researches an incredible species who is neither plant nor animal, and they're called the mint sauce worm. And I went to Jersey to find them, and we'll see them in a bit. But when he's thinking about symbiosis and about species colliding lives together for survival, he references a German biologist called Heinrich de Bary, who, this is like a summary of his overall understanding or definition of symbiosis, and it simply is those species who live with another. So symbiosis is species who live with another, and I certainly found that really helpful, from just for its simplicity and also its like relatability to how we govern ourselves within our own relationships between one another, but then also between with us and the natural world. But essentially, it represents this situation of life colliding together, sometimes even down to the DNA level, in a strategy for survival. Symbiosis as a word derives from the Greek word meaning living together. So again, I found that very helpful when I was trying to wrap my head around it at the very beginning. It's simply species living together. And ultimately, To Have or to Hold is a book about relationships, about nature's relationships. And that's the ultimate thing that we do on this planet in many ways, is to form relationships. And so I thought, well, that's actually quite a helpful way of looking at it for me when I'm trying to write about it in hopefully a way that draws in readers to this topic who may not have encountered it before. So to help me do this, I turned to Gaia. And in Greek mythology, Gaia is the goddess of the earth. It's like she's a personification of the earth. She's the mother of all living things. She represents Earth as a living, interconnected, holistic system. And Gaia formed the basis for the Gaia hypothesis, which is a really well-known, kind of well-referenced hypothesis that talks about the interconnection of the natural world, and was really propelled by James Lovelock and also Lynn Margulis, who we'll meet in a little bit as well. But Gaia has kind of pervaded popular culture and I guess the sort of social scene through experiences that like emulate serenity and peace and calm and wellness. When I first googled Gaia, the first thing that came up was the Gaia Spa experience at Borringdon Hall in Devon, which I can highly recommend. But I think we all kind of understand what Gaia means in terms of seeing Earth as this like maternal giver who can provide. And again, symbiosis for me, in my interpretation of it, fed into that hypothesis really well. And one of the things that sort of really sparked my journey, I guess, with symbiosis, when I first started to brainstorm the book, I was lucky enough to visit the I think it was called the Gaia exhibition, and it was a traveling exhibition by the artist Luke Jerram, who works on these amazing installations of the planets that are blown up, not obviously not to scale, but to a large enough scale where I think 1 centimeter represents like 18 miles of the Earth's surface. So he's done one of the moon, he's done one of Mars, and he's done one of Earth. And he hangs them and installs these enormous spherical exhibitions in huge rooms like cathedral naves and big hallways and things. And so he was doing an exhibition of Earth at Exeter Cathedral, which is my local cathedral, and I viewed it at night. And to see Earth suspended in the darkness of a really phenomenal space like the nave of a cathedral was really kind of hypnotizing in a way. And the whole point was Luke Jerram's aim for the piece was to make viewers feel the overview effect, which is a very commonly reported psychological feeling reported by astronauts who have experienced time and space, where they, if they're in an International Space Station, for instance, they look down on planet Earth and feel this almost indescribable feeling of awe and wonder and a desire to love and protect the planet as home, as mother, as Gaia. And so it was a really effective way of trying to emulate that feeling that is going to be so impossible and unrealistic for the majority of us. But it kind of can spark the flame of feeling protective and nurturing towards the planet, who seriously needs our help at the moment. So it was a very fitting way to begin my exploration of symbiosis, and how can we maybe hope to care for the planet better if we understand our place in the relationship and how extraordinarily connected everything is. Okay, so I'm going to do a little reading. These pictures are just clips from the film that you've just seen, but are very representative of the journeys that I've made. So in the book, 8 chapters, and each chapter spotlights a specific symbiotic relationship. I did go further afield this time, around the British Isles, so I did visit Ireland, and there we spend time in one of the best temperate rainforests in the world, one of the most ancient temperate rainforests in the world, and one of the most intact. And we're looking at Lumwood lichen, but also go up to Scotland again, go to the Channel Islands, Wales, and lots of time in kind of the south of England. And again, trying as best as I can to get to these places via low carbon means. So lots of cycling, lots of ferries, lots of trains and public transport. But I'm going to read a section. Hopefully you can hear me. The book is also available as an audiobook, read by me without a cold, so a lot better than what I'm about to do now. But this is an extract from the prologue, and here I'm describing symbiosis and hopefully piecing together some of the things I've spoken about already this evening. This tangle, this entwinement, this lively fusion of different lives is symbiosis. A lovely word, don't you think? Like the word Gaia, you may encounter myriad definitions of symbiosis, and you probably have an idea of its meaning. Maybe you have read descriptions of symbiosis that were presented to you using relatable human angles and connections. Sentences that include symbiosis often include words like mutualism and equality. Perhaps that's because those are the things we want in our relationships. When our relationships go well, we give and we receive. Is that why we want to believe relationships that work for us must also be good for nature? Except that isn't the case. The truth is nuanced and unruly. And so, before we begin, I kindly ask you to put all your preconceived notions and interpretations of symbiosis aside. You will find nature's variations of symbiotic relationships to be darker, far more shocking, and much more scandalous than you could imagine. In the name of survival, nature thrives on specific yet fluid relationships. Relationships as glamorous as they are grotesque and as bizarre as they are essential. Learning about some of them, we will see, know, experience nature at her best, brightest, and most raw. I've been told symbiosis is an art. In many ways it is, but when species have evolved to engage in these relationships, their life depends on it. For many, an elaborate interdependent life, having or holding on to one another, is the only way to survive. Okay, so that's a little extract there. And also in the prologue, I sort of introduce a couple of terms that I guess set the scene as to why I'm bothering to do this. I would only ever write a book that feels purposeful and that hopefully will explore topics and subjects that matter. Otherwise, it would feel incredibly self-indulgent. And I think it suddenly felt really urgent to me to write about relationships that exist in nature, because it felt like they have a lot to teach us, and that we can learn many lessons from how nature lives together in a kind of brutal yet beautiful, complicated, often unequal entanglement, but immensely sustainable. Like these relationships, some of them have existed for millions of years, so they must be doing something right. whereas our relationship with planet Earth is kind of a bit turbulent at the moment. And so I talk about a concept known as species loneliness, which sounds terribly melancholic, but it's again quite a helpful image to conjure when we're trying to figure out, okay, well, what is the point of talking about nature's hidden relationships, aside from being fascinated and feeling astonished and shocked by some of them? What lessons can we learn for how we go forward in our own relationships? So species loneliness was coined in 1993 to describe the kind of fundamental but unfortunately growing human dislocation from the natural world, from species and from one another, which is quite sad. And then solastalgia, I had never come across before, and I immediately thought, don't they mean nostalgia? But it kind of has a similar rooting in the word nostalgia, in that solastalgia describes the emotional distress of environmental change. So nostalgia is often rooted in a fear of change, but solastalgia is specifically a fear of environmental change. And I'm sure many of us here this evening can think of a time where we have felt solastalgia and perhaps even species loneliness. And if any of you have read any of Robert Moore Kimmerer's work, who wrote the incredible Braiding Sweetgrass, among other essays and short stories and kind of meditations on the natural world, she talks about things like species loneliness really beautifully, in a way that kind of there's a very hopeful way of looking at that as well. But I think my ultimate question, apart from questioning are we ever alone, which of course we're not, is when I started writing a book about symbiosis, I did not expect to be basically writing a book about parasites. And parasites and parasitology and parasitism, which describes a relationship where the suffering of one species enables the survival of another. They tend to be on the slightly more grotesque side, and repulse a lot of people, but they make up 50% of all animal life on the earth. So half of all animal life exists and needs a parasitic relationship to survive. And studies have shown, and the field of parasitology is kind of snowballing in its urgency at the moment, because they're realizing that actually everything is connected to a parasite in some way. So it's probably quite a good thing to be looking at, whether it's in meadows or woodlands or wherever. Parasites are everywhere. And so my main question is, okay, well, parasites have definitely, again, done something right in being able to be that successful and that ancient and that connected to so many other species, like an invisible web, a bit like fungi. And the fungi is in many ways, as we discover in the book, a parasite. And that's not a bad thing. It's just culturally got a terrible name. And so I started to suddenly find these parallels between us and quintessential parasites, in terms of, well, if parasites must inflict some level of suffering on their host, are we a parasite inflicting suffering on our host, the planet? And is actually there anything that we can learn from parasites as to how to be a better parasite? Because we're at a tipping point where parasites need to keep their host alive, and in many cases thriving, in order to extract the resources that they need. But they don't want to be so extractive that they run out, because they want to complete their life cycle. So what can we learn from parasites as to how to practice a bit more restraint? But we're going to be talking about that a little bit. But I'll read you another short, it's a lot shorter this time, extract that kind of introduces that. Again, this is from the prologue. There's a lot of scene setting here. In Ecuador, for example, nature has legal rights. The rights of nature is not a concept, it is law. Since 2008, part of Ecuador's national constitution has recognized that Ecuadorians should protect every living being, from mangroves to trees to beaches to captive monkeys, for their moral and spiritual intrinsic value. In contrast, in the UK, as of 2024, there is still no legal right to a healthy environment. Instead, I am desperately voting for change in an era that feels increasingly torn, overly digital, politically vacant, ecologically starving, and layered in deceit. Meanwhile, nature arches her back under the strain of floods, drought, wildfire, pollution, and biodiversity loss, rearing her head, writhing in pain because we have taken more than she can give and have so little to offer her in return. And yet, even in her agony, she holds us still. It begs the question, are we in a parasitic relationship with Gaia, our communal mother? When we feel climate anxious and our environmental despair makes our hearts ache, are we glimpsing the suffering we inflict on our host? Stranger things have happened. So, I guess that's that. But the main kind of, there's a lot of, this book is a lot darker than Forget Me Not. A reader wrote to me a few months ago and said that it's like Forget Me Not's gothic cousin, which I thought was a very accurate description. But there is a lot of light in amongst the shade, and Symbiosis by its nature produces some of the best stories I've ever learned about the natural world. And to the point where I'm like, sorry, I just need to clear my nose. To the point where, you know, in zoology, we did a lot of parasites and stuff, which I found fascinating, but I was like, why didn't we do more? It's so amazing. Nature's so weird and wonderful. These are some pictures from some of the trips. From the left, we have lots of lovely lichen. So I was lucky enough to spend some time with the amazing ecologist and naturalist Stuart Taylor, who's based in Abernethy in the Cairngorms, and he's done a lot of work with the RSPB up there in aspen forest conservation, and is a real pioneer, really, in how aspen forests are returning and being restored in that part of the UK. And just seeing Stuart at work in his environment with a hand lens is a real privilege. So I was very excited to spend lots of time with him looking for the aspen hoverfly, and also aspen bracket fungus, and that kind of really amazing symbiotic relationship where death is the gateway to symbiosis. So death and decay enables a spectacular collision of life that enables the survival of the aspen hoverfly, one of the rarest hoverflies in the UK or in the world, really. Whereas another species, like the lungwort lichen in Ireland and the temperate rainforest, that actually was also in this part of Scotland, we found one amazing specimen. Death is the end of symbiosis. So in death they part. So playing on that vow, I guess, of to have and hold, to have or to hold, offering us that choice there. And then on the right, I am on a catamaran with the amazing marine discovery in Penzance in Cornwall, looking for the ocean sunfish, the largest bony fish in the world. Instead, well, spoiler, instead we saw some amazing common dolphins, which are below. But the sunfish I chose because they are the most parasitically burdened animal on Earth. They can host up to 400 different species of parasites on their bodies at any one time. Yet they still circumnavigate the ocean, survive, reproduce themselves. And so science is like, how on earth are they able to bear this burden, but also connect sea, sky, and land all together just through the landscape of their bodies? They're amazing. And we ourselves, of course, as humans, as mammals, are host to around 400 species of parasite as well. And not at the same time, of course, whereas the sunfish can accommodate that at once. But at some point throughout our lives, our bodies are an optional host for so many different parasites who need us to complete part of or all of their life cycle, which is kind of amazing, I think. We facilitate the lives of so many others without even realising. I want to introduce you to this amazing lady, Professor Lynn Margulis, who was a real inspiration to me for many reasons throughout writing this book. She's unfortunately not alive anymore. She died in 2011, but she really propelled and worked a lot with James Lovelock. The theory of endosymbiosis, which I'll read a little extract from in a moment, but she was a woman who was whose ideas were seen as too soft and too creative almost, despite being an atmospheric chemist and an incredible biologist in her own right, very, very distinguished. But it was seen as too feminine an approach to the kind of hard and fast Darwinian theory of evolution. And yet, all these years later, her work is being referenced a lot, and is Professor Tim Lenton of Exeter University, who founded the Global Systems Institute, which is one of the world's leading climate institutes in the world, and who also authored the IPCC reports every year, the massive global climate report. Worked a lot with Lynn Margulis, and hearing his stories of working with her confirms that she was indeed an amazing woman. Quite controversial, not to be messed with, but I think that's what got her, made her successful. So I just want to read you a little bit about Lynn, and then we'll move on. Lynn Margulis was 28, my age as I write this book, when her 1967 paper on the origin of mitosing cells rattled the hallowed corridors of science, leaving bemused, mostly male, academics floundering in her choppy wake. Before it was accepted and published, the Journal of Theoretical Biology rejected her paper 15 times. Many claimed the theory she put forward in her paper was little more than a story. Lovely, they might have said, but the science was soft. Her work could never be compelling. Until this point, the accepted route to life on Earth was founded on the elements of chance and competition, on mutations and natural selection. Nature's arms race was sensible, precise, and logical. Science girded itself on these principles. In the race to survive, all organisms recruit and deploy every available resource in a battle to become stronger, faster, more immune, more exacting. Because only the fittest, under specific environmental conditions, develop the resilience to survive. Because Charles Darwin said so. And while all of that is true and reasonably thrilling, we should know better. Lynn read this rulebook, nodded in agreement, and then obliterated it. Her background in biology and atmospheric chemistry magnified the mysteries of cellular life so the rest of us could gawp at them and have our tiny minds blown. While many of her colleagues were inclined to accept that all the species we know of must have evolved aggressively by tooth and claw, Margulis was captivated by the additional evolutionary options that came from studying species that live together and sometimes live inside one another. Where other scientists saw a single animal cell as an evolved individual rattling around alone in a detached house, Lynn observed a thriving bacterial community renting shared accommodation. Lynn organised her thoughts into her ground-shaking 1967 theory of endosymbiosis, in which she passionately advocates that organisms are more mobile, more organised, and more driven towards destiny than we give them credit for. Organisms are active, not passive, she insisted, because nature cannot wait. So I found that all that very exciting. And if you do a bit of research or Google Lynn, you'll see the impact she had and the legacy that remains. And it was really cool that many of the scientists who I worked with for research and I guess credibility in this book reference her with such high praise. So yeah, very special lady. So I went to find some species. The travels were an immense highlight. I also had the challenge of, for some reason, nearly every single trip was accompanied by a named storm. Now, we've just had Storm Amy, which I'm recovering from. 100-mile-an-hour winds, no power for 48 hours, no phone reception, no hot showers, no hot meals. And when you're doing an endurance hike, those are the essentials that you hope are waiting for you at the end. Safe to say, I didn't have quite that level of extreme, but traveling with so many storms throughout the year was difficult. And apart from it being quite frustrating and kind of thrilling sometimes, I started to ask the question of, well, actually, what is going on? Because the weather just felt strange. It felt really turbulent. This is part of the big bike ride, from London to Brighton that I did with my best friend Harriet, to go and find the early spider orchid and the buffish mining bee. We had Storm Agnes, I think was that one, And yeah, 70-mile-an-hour winds on a bike for 7 hours for 100 miles was tricky, to say the least, but a good adventure and great to do it with a friend. But when I started to do the kind of background research and trying to link all of these relationships to climate change, because that was a non-negotiable part of the narrative for me, was, okay, well, these relationships have existed for millions of years, but with climate change disrupting the world as it is, what does that mean for these relationships? Could it break them up? Could it introduce new participants onto the scene? Could it sever bonds forever? Could it bring them closer together? I was keen to know that story. And when I was doing lots of research on the Met Office and what they were saying about the years of 2023, 2024, they were years of exceptional weather for the UK. We had heat waves, we had drought, we had flooding, and we had many, many named storms. And so that is, instead of it being something I sort of want to forget and maybe gloss over and sugarcoat in the narrative, it became a real talking point. And I guess I'm grateful for that. But yeah, it was important for me to try and get like even a glimpse of what these species live through, and if I can kind of feel through pushing myself through a landscape kind of an ounce of the challenges that they face in the kind of terrain and weather and landscape, then it hopefully helps me write a bit better when I come back to my nice cozy desk. So how is climate change affecting some of these species? I can't take credit for any of these photos bar the top right, which is the amazing mint sauce worm, which I'll tell you a bit more about that in a moment. But it's a real interesting picture. So from the top left, this is a picture of a hairworm emerging from a cricket or a grasshopper. I need to put my glasses on to see properly, but hairworms are like your quintessential, your archetype parasite. If someone was to say, think of a parasite, the way that they manipulate the host to do whatever they want, and to perform acts of which they would never dream, is kind of exactly what a hairworm was born and built to do. So hairworms need multiple hosts to survive, and incredibly, they are indicators of good water quality, and they connect at least 5 different lives together. And so if you think of a healthy river system, which is sometimes unfortunately difficult to think of in the UK at the moment, if that river system has a healthy breeding population of hairworms, you can be pretty sure that there's also a healthy-ish population of invertebrates, from aquatic snails to mayflies to terrestrial invertebrates like grasshoppers and crickets to water beetles and things like that. They connect so much life in those freshwater and saltwater kind of wetland ecosystems. And they essentially, when they're adults, they occupy the head region of their final host, which is a larger insect like a cricket or a grasshopper. And then and scientists don't really know how they do this. So I was very lucky to kind of tag along with a research team in Bath, who's like the research lead group around the world for understanding how hairworms make species do what they want, how they have the species under their thumb, so to speak, and kind of do their bidding. But they know that they occupy the head region. They know that they have some amazingly finite control over their neural system to instruct a walk back to freshwater. So if you Google a hairworm, you may well see videos of insects leaping into the water in a kind of what's called a suicidal leap. And as soon as that insect that has a hairworm in it touches the water, the hairworm spills out of the head and then will go on to mate and continue their cycle. It's a phenomenal process. I just find it absolutely fascinating, but so many people find it gross and then switch off. But let this be an encouragement to maybe view it as a new way to see the world and allow the awe and wonder to come in. It might take some time, but that's my hope. But what is interesting from a kind of climate change, changing world point of view with the hairworm is they connect the dots between lots of different species, but they need that water quality to be good. They need it to be high in oxygen. And And so water quality issues are a real issue for them, as is extreme weather and flooding. Suddenly a tiny stream becomes a completely inhospitable tidal wave. But then what's also interesting, especially when we're looking at species that require sound and song, like crickets, is noise pollution. So in Europe, around 60% of the population lives under a soundscape, decibels wise, is equivalent to the sound of constant rainfall, which is a lot, really. And so if a species like a hairworm is reliant upon the sound of a cricket in order to kind of attract the host or whatever, and there's that interplay, if they're unable to detect species for one reason or another, that might mean that they'll never meet, which would spell the end of a hairworm for sure. Artificial light is also a potential issue. So a fascinating kind of strand of this sort of investigative research that this team from Bath were doing, where they were like, okay, well, if the hairworm is in the head of the cricket, how can they navigate back to a body of water, assuming they're in a field somewhere? The cricket's found the hairworm, eaten it, and then it's gone up to the brain region. And so what they've hypothesized, and I don't actually know if there's an update here, this was last year that they were looking at this, is that the hairworm, through the body of the cricket, were using celestial cues as a compass. So reflected moonlight off of fresh water in a forest, or reflected starlight. And yet 80% of the world lives under artificial light. And so if that is disrupting and spilling into forests and streams and wetland areas, species who rely on those celestial nocturnal cues to navigate, whether it's a hairworm or otherwise, might be in real trouble of being unable to do that. And in that chapter as well, I also talk about research that's a little bit more extensive about hosts and parasites who basically the connection is severed due to anthropogenic impacts on the natural world. Moving to the right, if we're looking at lungwort lichen, which is an astonishing trio of an algae, a fungus, and a cyanobacteria, so double the photosynthetic power of a normal lichen, which normally just has either a cyanobacteria or an algae as their photosynthesizing factory. But lungwort lichen has double, which is amazing. And as I mentioned earlier, if any one of the trio dies or leaves the relationship, it's game over for the whole organism. So death is their end, as is for us all. But lungwort lichen has been very, very endangered and has had its range massively restricted due to air pollution. It's incredibly sensitive to changes in air pollution, which is why it exists in just the fragments of temperate rainforest that remain across 1 to 2% of the British Isles is all that's left. It once carpeted, I think, up to 20%. And so it's a real indicator of good air quality. So if you're in a region, in a forest, on the kind of West Atlantic shores of the British Isles, and you spot lungwort lichen, you can be pretty sure that the air that you're breathing is really, really good, especially if that lungwort lichen is kind of large and thriving and looks lovely and luscious and green as it does in the photo. So air pollution is a real kind of game over situation for lungwort, unfortunately. Sunfish in the bottom left, the wonderful weird alien that is the lovely sunfish. That's a really interesting one. The climate change link is not clear at all. But when I was looking for it, we were in a real big, intense marine heat wave, and we've had 3 or 4 of those again this year, which is kind of quite concerning. But what I never really anticipated in writing a chapter about being in the middle of the ocean was talking about terrestrial drought, so drought that occurs on land. And I met this incredible researcher called Professor Angus Atkinson, who does a lot of work with the Plymouth Marine Laboratory, works with British Antarctic Survey, does lots of work with plankton and kind of how plankton circulates around the currents of the world's oceans. And he was explaining to me how if you have an area on land that is undergoing drought, that directly affects the nutrients that are outflowing into the ocean. And those nutrients that are flowing out into the ocean after periods of rainfall or water rivers and spate, or just kind of in an estuary flowing out into the sea, as you would expect, those nutrients are really important for feeding phytoplankton, zooplankton, species at the very bottom of the marine food web that then end up supporting giants like the ocean sunfish, like killer whales, like sharks, dolphins, all the marine predators. And what they're finding is that with terrestrial drought and with marine heat waves, species are actually shrinking. Fish are shrinking in the ocean because they're not getting the nutrients they need. So they're evolving to be smaller to require less. So it's, on the one hand, an incredible example of nature showing true grit in the face of adversity by evolving to shrink, but it's also a very kind of unsettling reality of drought all the way inland can affect the species like plankton, who are responsible for every other breath that we breathe. Such is their oxygen production. What else have we got here? We've got the crab, the shore crab, and the saculina barnacle, which is the blob at the bottom of its kind of front of its carapace. The barnacle invades the body of the crab and then emerges on the outside looking like a false egg sac. So it makes the crab believe that it's pregnant. The crab then decides, or not decides, the crab is then kind of fooled to protect and nurture the parasite as it would its own egg sac, which is, again, I find incredible, but a lot of people find disgusting. But the crab and the barnacle story here, there's a link to marine disease and how disease is spreading through the ocean and causing big events called crustacean die-offs, where there's a lot of unanswered questions in the sort of research departments that look at these events. There's not really any one single factor pointing to crustacean die-offs, but a lot of it does come back to marine pollution, which is obviously a massive, pervasive, ongoing issue. And then in the bottom right, we've got the early spider orchid, which is a beautiful orchid. And the story here of climate change is spring creep. So the advancing of the season of spring with climate change. Spring is coming earlier, things are flowering earlier. And the early spider orchid is exclusively pollinated by a solitary bee called the buffish mining bee. And it's exclusively pollinated by the male buffish mining bee. And the way that this orchid lures in those male bees is by having a chemical scent that is nearly exactly to the compound the same as the smell of a female buffish mining bee. So the male buffish mining bee will see the flower, think it's a female bee, and attempt to mate with it. And in the process of trying to mate with it, gets himself covered in pollen. And then by the time he's realised, oh wait, it's not a female bee, he's covered in pollen and has ensured the survival of that flower. And then he can go off to find another female bee if he so desires. But the trouble is that climate change is throwing all of this amazing synchrony out of whack. And I spent a lot of time understanding the life work of Professor Michael Hutchings of the University of Sussex, who is like the expert in orchids, especially the early spider orchids. And he authored and led what has become the kind of lead groundbreaking study showing how climate change is impacting species. And it was a 32-year study. This climate change was not the focus at the start of the study, but it became an inevitable focus. And what the kind of ultimate conclusion, after there are many conclusions in it, it's an incredible piece of work. But when recordings of early spider orchids, and this is, I guess, really pertinent to Moor Meadows actually, when it started in 1975, 32 years later, the early spider orchid is now flowering roughly 2.5 weeks earlier than it did when recordings started in 1975. And so the trouble is that the flower of the orchid needs to be the first to come out, needs to be in flower and attractive and smelling great. Then the male bee needs to emerge, and then the female bee needs to be last to emerge. But what's happening is that with spring coming earlier and everything, the female bee is emerging before the orchid is in flower. And when that happens, if a male bee is out and about buzzing away, if a female bee is on offer, he's going to go and mate with her, not the flower, because she's the real deal. And so if the early spider orchid is unpollinated, it could die out. And it's more a cautionary tale in that the world is not going to implode, unfortunately, if the early spider orchid were to go extinct. But it's more, you know, if that's happening to a random orchid, what else are we missing that could go wrong, with all these kind of timings and seasons blurring into one another and going out of kilter. And I also talk in that chapter about, again, going back to artificial lights, light at night. It can actually keep pollinators working throughout the night and flowers photosynthesizing, because they think it's daylight, to the point where actually they experience burnout and become physically exhausted and die, as you would if you were in a gym constantly for 24 hours a day, 7 days a week. So that was something I hadn't considered and was very kind of surprised by, but also made total sense. So that's a little bit about how climate change is affecting those species. And I just wanted to talk a little bit about the mint sauce worm. So here it is. It looks like a green algal mat. You would probably look past it if you were just on a walk at low tide, maybe in Jersey or maybe in parts of Cornwall and Wales. But look a bit closer and it's actually millions and millions and millions of 3mm long worms. Now, these worms have decided they don't just want to be an animal, they would also quite like to be a plant. And so they have absorbed millions of single-celled algae from the surrounding seawater to colonize their muscles, their tissues, turn themselves green. And what do algae do? They photosynthesize. So they provide movement, locomotion, food, energy for the worm, who otherwise couldn't really do all that much. And the question here is, and this is the first chapter, it's a brilliant kind of introduction to the magical mysteries of symbiosis and kind of the darker tale of it, compared to the sort of everything is kind of happy and mutual and everyone's getting something and returning things as well. But it's the tussle between the animal and the algae, the worm and the algae. Who's really winning? Who's losing? What are they getting out of it? And yeah, it's a really amazing species. And I want to show you this video that someone sent me. So I was on Jersey looking at them, studying them, loving them. And a few months ago, they sent me this video of it's just a really nice close up. I'll skip it along a little bit. Of the worms, and you can just see how luminous they are, and that is all because of the algae. And these worms move and kind of rise and fall with the tide as a collective. They live in these enormous cities and kind of societies with one another, and they rise to the surface of the seabed at low tide. So when the tide goes out, all the worms rise up from the seafloor or the seabed, kind of in the sand, and then expose themselves and lie on those mats and that picture I showed you earlier in order to photosynthesize. And then when the tide comes in, they descend en masse to the safety of the sand. It's a phenomenal movement, and the study of these worms is informing amazing things like cancer research in terms of how the algae are proliferating inside the body of this worm. Could that inform the way that tumours grow and proliferate in a body? But also the way they assimilate waste and recycle waste and undergo oxidative stress and kind of cleansing in their body is informing waste recycling on the International Space Station. So never underestimate a worm is the motto there. But again, I think they're absolutely amazing. Again, I guess I'm kind of thinking here, like, what is the future of nature's hidden relationships? What is the future of symbiosis? What can we learn? What are the lessons that we've learned from some of these relationships? And again, most of the lessons have come from the parasites of the relationship, which I wasn't expecting. And they're things that are really basic, like take only what we need, take a sustainable amount of resources to keep our host alive and thriving, exercise restraint. there's some research in the sunfish chapter where I found that there are parasites who lessen the toxic burden of a host by absorbing the toxins in their own bodies to keep their host as healthy as possible. So there I was like, well, maybe parasites are teaching us to leave the environment in a better state than we found it. And parasites teach us to, or kind of challenge us to see the natural world in a new perspective. It's not built on equality. Most of these symbiotic relationships are kind of thriving in a remarkably sustainable way on exploitation. It's unequal shares. Nature's not built on equality or egalitarian things. It's brutal, it's explosive, but it has found this amazing balance. And so there's a lot that we can kind of reflect on in that. And then I just wanted to share the fact that I felt very lucky to collaborate with the amazing artist and illustrator Abby Cook once again on this book. So Abby illustrated the cover of Forget Me Not and the internal illustrations, and she just did the internal illustrations this time, but she did a wonderful map of the British Isles at the very beginning to kind of place us, help us find our feet with where we're going across the book. And she's just done some beautiful kind of graphic-y illustrations of the species in each of the chapters. So we've got the sunfish, we've got the hairworms, the early spider orchid, mint sauce worm, the crab and barnacle. And it's such a pleasure to kind of collide science and art together. And I think from a storytelling sense, it really helps elevate the words when you have an artist who can really help a reader visualize species who they may have never heard of, let alone encounter. So I feel very grateful to have that help and assistance there. But that's it really. That's To Have or to Hold, a kind of whirlwind of a tour. Do read it if you're interested, or listen to it. It's kind of out wherever you buy your books. I'd recommend you support an independent bookshop where you can. There's lots around Devon if you're based in Devon who are very kindly stocking it. But yeah, I hope you enjoy, and thank you very much for listening, and I'm happy to answer any questions.
Well, thank you very much, Sophie. That was a fascinating talk with some really interesting examples. A lot to take in. It's incredible.
Yes, it is a bit.
Really interesting notion that you said that we are the parasites on the planet. There is much for thought, food for thought there.
Meal for thought, yeah.
Meal, yeah, absolutely. I think we haven't got a huge amount of questions. I think, again, probably because it's such a lot to take in.
It does take a while. I found that it takes sort of a few minutes to let the sort of subject percolate, and then one or two questions help sort of fire things off.
Yes.
But, no pressure.
We have a question from Charles Sinclair, who says,
hello, Charles.
Do you think that most symbiotic relationships are the result of parasitic relationships that become resolved?
Ooh, that's a really interesting question. I've not had that one before. Resolved. I'd love to know what you mean by resolved. As in that implies in conflict resolution.
Yeah, well, answer. Yeah, maybe have yeah, whatever you think that means.
Maybe. I mean, I think the fact that every living thing is caught in symbiosis and a kind of parasitism at some point in their lives is, I guess, an indication that most symbiotic relationships are the result of a parasitic relationship. What the term resolved means, if it means like that they've found a sustainable way of life and they've found a balance that can be replicated and sustained for millions of years, I'm not sure, but I don't know whether to go philosophical or scientific with that, but Charles, if you were able to clarify, that would be really helpful. Sorry, that's not a very good answer at all, but thank you for asking.
Does anybody else want to ask Sophie?
I'm also happy to answer questions about actual book process itself, whether anyone, I know there's probably quite a few writers in the audience and people who enjoy documenting the natural world by word. So yeah, happy to answer anything.
There's one from John Walters, has researching the book changed your life at all, or has it caused
Oh,
you to change
wow.
where you live? Interesting
Oh,
question.
that's a really interesting question. Thank you,
Mm.
John. Researching the book changed your life. I think it's made me, it required a lot of introspection and a lot of reflection on my own relationships, personal, like professional, family, everything. And it was also like a serendipitous moment, I suppose, that in the middle of the whole researching, traveling, writing year, I also got married. So that provided, I guess, naturally a lot of chance for quite deep thought. And I think it's just I made a conscious decision to, which you may have picked up on, to who nature and to animate nature with a grammar of animacy. So who, he, she, they, instead of an it.
Mm.
And I know that that's a scientific taboo. And I had a couple of the scientists who very understandably, and I totally understand their concern, were quite uncomfortable with me doing that because they said it kind of belittled the science. But actually, I think we're at a really exciting turning point in science communication where that grammar of animacy is being really embraced. And for example, Robert Macfarlane, in his amazing book, Is a River Alive? That is the question. That is the whole point of that book, is actually we should be seeing nature as a living, breathing, pulsating being who we can feel privileged to live alongside, and not an alien it who we like to view from a distance. So it was important to me, I guess, in answer to your question, John, changed my life, changed the way you live. It changed the way I wrote, which at the moment is a big part of my life. And I wanted to have a more intimate language when writing about nature, and whoing it and he, sheing, theying it was a really, it felt powerful to me to do that. And I really enjoyed that challenge. But it was amazing how difficult it was to kind of shake the habit of itting nature. Like even in the final draft, we were there like, oh, there's an it. Whoops, let's change that to a who or whoever. And I know it's not for everyone, but that was a personal decision that I feel like was the right one for this book for sure.
Brilliant, thank you. I agree. I find that fascinating. I think it's important. Yeah. So Jill B has said, do you see the world as more or less chaotic since researching this topic? I mean, nature is more or less chaotic. Oh, Sophie seems to have frozen. Let's see if she comes back. Hello, Sophie. I can't answer that one for you, I'm afraid. That's going to have to be a one from Sophie. And John, you're right. She gave a fascinating answer to her to the question you gave her. I think that I think Sophie's had to drop out of the studio, I'm afraid. So anyway, we'll have to wrap up now, and just to say that this is the last of our autumn talks, and next year we'll be having more inspiring online talks, including talks on increasing species diversity in grasslands. We've got a talk on glowworms by Pete Cooper coming up in the new year, and the fascinating topic of ghost ponds. To make sure you don't miss any of our talks or events, you're very welcome to subscribe to our newsletter. If you haven't already, you can find that or how to join on the Moor Meadows website, www.moormeadows.org.uk, and if you just click on the join button. And finally, if you have a meadow anywhere in Devon or the southwest, no matter the size, please consider adding it to the Meadows map, which is also on our website. And it's a fantastic way to show the collective impact of everyone helping reverse wildlife declines As of this week, we're at 3,346 acres. Yay! So a huge thank you to Sophie, and thank you for all of you for joining us tonight. And hope to see you at the next talk. That'll be March, April next year. Good evening.